Welcome to homework.
So here in this problem we are given a rigid tank that contains 5 kg of saturated vapor stream. So mass we are given as 5 kg and initial temperature is 100 degrees Celsius. Now then the steam is cooled down to the atmospheric temperature of 25 degrees Celsius. And there are three parts in the problem. In the A part we have to sketch the process with respect to TV diagram. So first of all I will be sketching the diagram. So here you can see the TS-TV diagram. This is the answer for the A part, and this is the point state 1 and this is state 2. So state 1 is saturated vapor, that is why it is shown at point at this saturation curve, and then the point 2 is the steam is reaches to 25 degrees Celsius. So this is 25 degrees Celsius. So this is solution for the A part. Now next I will be doing the B part, and in the B part we have to calculate the entropy change of the steam. So to solve this, we'll be using the table A4 and A6 to find the required input data. So initial condition is T1 we have 100 degrees Celsius and the quality of the steam is 1, or we can say the dryness fraction is 1. So for that we'll be calculating the specific volume V1 and it will be equals to Vg, and from the table we'll get it as 1.6720 kilojoule over kg. And next U1, that is the specific internal energy, it will be equals to Ug, and that is 2506.0 kilojoule over kg, and the unit of this thing is meter cube over kg. It's not kilojoule over kg. And the specific entropy S1, it will be 7.3542 kilojoule over kg Kelvin. Now state 2, the condition is T2. We are given as 25 degrees Celsius, and since it's a rigid tank, so we can say the volume remains constant. So V2 specific volume will be equals to V1, and that is this one, 1.6720 meter cube over kg. Now at this state we will be calculating the value of U2 and S2, but before calculating this value we have to calculate the dryness fraction at point 2. At this point we have to calculate the dryness fraction of the steam. So X2 will be equals to V2 minus Vf divided by Vfg. So V2 we have 1.6720 minus Vf will be corresponding to this temperature 25 degrees Celsius, and from the table we'll get it as 0.001003 divided by Vfg is nothing but Vg minus Vf. So Vg from the table is 43.340 minus, and Vf we have 0.001003. So after solving this we'll get the dryness fraction as 0.03856. Now we can calculate the value of U2. So U2 we know it is UF divided by UF plus X times UFG. So this is X2 basically. So UF from the table corresponding to this temperature will be 104.83 plus X2 we have 0.03856 times UFG is 2304.3. So after solving this we'll get the value of U2 as approximately 193.6 kilojoule over kg. Now next is S2. So S2 is SF plus X times X2 times SFG. So again using the same table we'll get the value of SF as 0.3672 plus X2 we have 0.03856 times SFG is 8.1895. So after solving this we'll get the value of S2 as 0.683 kilojoule over kg Kelvin. So we have obtained all the values. Now we can calculate the change in entropy, and change in entropy, that is delta S, it will be equals to m times S2 minus S1. So we'll be using this formula to calculate the value of entropy change. So mass we are given in the equation as 5 kg, and S2 we have calculated as 0.6830 kilojoule over kg Kelvin, minus S1 we have calculated as 7.3542 kilojoule over kg Kelvin. So by solving this, we'll get the change in entropy of the steam as minus 33.36 kilojoule over Kelvin. So this is the solution for the B part. Now next, in the C part, we have to calculate the total entropy change associated with the process. So for that, we'll be using the energy balance equation first. So energy in minus energy out, it will be change in energy of the system, and there is no energy input to the system, so this one is 0. Energy out is Q output, we are given as minus Q, this is Q out, and it will be delta change in system will be change in internal energy, that is M times U2 minus U1. So from here we can calculate the value of U out, and that is equals to M times U1 minus U2. So we can plug all the values here. M is 5 kg, and U1 we have calculated as U1 we have calculated as 2506 kilojoule over kg, minus U2 is 193.67 kilojoule over kg. So after solving this, we'll get the value of Q out as 11,562 kilojoule. Now the total entropy change, that is delta S total, or we can write S generation, entropy generation. It will be equals to delta the entropy change for this steam water plus Q out divided by temperature of ambient or the surrounding. So we have all the values here, we can plug it here. So S delta SW is we have calculated as this one, minus 33.36 kilojoule over Kelvin, and this Q out is 11,562 kilojoule divided by the ambient temperature is 25 degrees Celsius we are given, so we have to convert this thing into Kelvin, so we'll get 298 Kelvin. So after solving this, we'll get the total entropy change of the process as 5.44 kilojoule over kg. So this is the final answer for the C part. So I hope you got the problem. Thank you.